R capital T, RF capital T. So this is the requirement they want that you have a cash account. Okay? Now, in the case of a future, the contract is settled in such a way that it is as if every day you close the contract and you open a new one. Okay? So in practice, what's the problem you have when you deal with a standard forward contract over the counter? That it might be the case that your counterparty disappears and you know, say 3 months from now what's going to happen, right? So in the futures agreement, you want to standardize the contract to deal with a contract that is essentially independent from the person you are dealing with through the central counterparty. For that reason, you need to standardize the dates of issuance. So there is a pre-scheduled set of dates where you can trade, where you can exchange the commodity, the good, and all these conventions are, you know, you can find online or you can find on the John Hall book. On top of that, so you have exchange trade. So essentially, what's the value added from having this standardization? That you can go and every day trade that contract in a liquid market. Okay, so it's liquidity, the value added. And we cannot value this value added because of this assumption one, right? But the future is far more liquid because each time you want to leave the market, you will find somebody, the counterparty, the central counterparty, that is accepting to trade, for example, okay? So, the cost you pay is that the cost is standard, the contract is standardized. It means that the contract might be not exactly the one you like, but it should be close, but it might not be exact. We will define a basis risk. So the risk that there is a contract that does not exactly match your requirements. There is a specified range of delivery dates. As I was mentioning, every day the contract is settled. What does it mean settled? It is as if you were closing the contract and reopening it. This is the settlement, okay? So the fact that the contract is usually closed out prior to maturity, okay? This is not really a condition. So generally speaking, people that are willing to speculate on securities, because of the leverage convention that you have, so essentially by putting a little bit of money, you can buy multiple future contracts. So the speculators are active in this futures market. And by the way, the closer you go to the final maturity, the more relevant becomes let's say, the real delivery. So if you're a speculator, you don't want to get involved in, say, all the technicalities about delivery, right? Because the delivery is technically demanding. For example, you know that oil has a storage cost, has multiple costs. So having oil in ship in the North America or having oil, you know, in the Arabic Gulf is very different. So if you are willing to speculate on oil, generally speaking, you don't want to face this type of physical problems. You want to stay away from these problems. This means that you will liquidate your position before the due delivery date. Okay? So, because of the liquidity of this contract, it's much better to do that. It's only possible to do that through futures because the forward contract do not allow to do that, right? Because they are not settled over a daily basis. It's, you know, futures, because of this augmented liquidity, you have the cost of the liquidity, but you have the benefit that ideally, as I was mentioning, the central counterparty is credit risk-free. So the risk that your counterparty, you knock at the door or you ring at the phone and nobody is answering is very, very low, okay? In the history, only few cases of CCP defaulted. Okay? Okay, you see, here we are This is the bilateral on the left. This is associated with forwards. The central clearing is associated with the future. Okay, now what is left is the mechanics of the future. So I remember there is a nice picture, so I'm searching for this picture, and then we are done. Well, before going to the mechanics of the future, let me define the basis risk. This is a key notion. So what is a basis risk? This applies to forward and future contracts, but is a more general notion. It is a risk that you are using a contract that is not exactly the one that matches your risk. Okay? Just to give you an example, while I was at the ECB, there was a basis trade between the physical treasury and the future on the treasury. So what is this basis risk? Essentially, when you deal with a liquid product that is standardized, as I was mentioning, there is the risk that there is no perfect match between what you would like to have and what you can trade. Okay? This mismatch, let's say what in mathematics you would call a simplifying assumption, will cost you. So the idea is I have to deliver my wheat, say, June 15. But I don't have a future expiring in June 15. Okay? So this means that if I want to go for trading a future, I will have to hedge the movements until June 15 by using a contract that maybe is expiring in June 30. Okay? So this mismatch causes you an additional risk because in a way you are forced to trade a contract and you are not sure that this contract is pinning down the value exactly at the date at which you have to deliver your physical good. Okay? So the future is entitling you to deliver a physical good June 30, not at June 15. Okay? So the mismatch between the contract you are using for your hedge and so the financial contract you are using for your hedge and the contract you would need to hedge exactly your physical risk is named the basis risk. Okay?
So can you repeat the
yes.
Do that with 100%.
So assume you have to deliver 1 ton of wheat June 15. Mm-hmm. But you want to be staying on the safe side, and so you want to trade, to hedge your risk, to pin down the price, not using a forward contract, using a future contract. And you don't find in the market any future contract expiring June 15. You say, okay, but given the movements in my price, I can take a future on a longer date, say June 30, expiring June 30, and I will use the contract expiring June 30, the future contract expiring June 30, to hedge the risk of my delivery June 15. Okay? So, this mismatch between the delivery date of the future and the delivery date, your physical delivery date, creates a risk in your financial risk in your portfolio, right? This risk is named a basis risk. Okay?
So it's basically not considering the whole amount of your risk and not hedging for it.
No, you are going to use this financial contract to hedge away your risk, but the contract that is available is not perfectly matching your hedging needs. Okay? Why it is interesting to look at this quantity in the case of the futures? Because we have an exact counterpart of a contract, of an ideal contract we would love to have. So, what's the additional flexibility, the value of additional flexibility you have if you decide to go for the forward? Well, in a forward contract, you call your counterparty and you can decide to have as delivery date exactly the delivery date that matches your physical delivery date, right? So, in our example, June 15. Okay? So, while in the case of a standardized contract like the future, it is the stock exchange that decides the delivery date. In the case of a forward, you may decide, you may agree with your counterparty about an exact delivery date. Okay? So, by comparing the price of the future and the price of the forward and the price of the underlying at the delivery date, you have a precise formula that quantifies the additional value of flexibility that you have because of the forward agreement is more flexible compared to the future agreement. Okay? Essentially, this formula is expressing everything in terms of the cost of the underlying asset as 2. So you see, 2 is the time of the purchase. In this case, for example, you are not thinking about, no, it's correct, it's purchase of wheat, okay? Your S2 will be the date of purchase, okay? F2 is the price of the future at the time of purchase. F1 is the future's price at the time you set up the hedge. Okay? That formula is the one that is B2 is equal to the basis risk. Okay? So you see, what's the intuition about this quantity? Well, you see that if you are in the situation where S2 is equal to F2, there is no basis risk, right? If you were able to settle everything at 2, the basis risk would disappear. It is the mismatch between date 1 and date 2 that creates this basis risk.
If S2 is equal to F2, there's no basis risk.
Yes, because that would imply that you have a forward agreement that is expiring exactly at the date where you know a future that would be equivalent at that point. That is, yes?
The basis risk is the difference between F2 and S2.
No, it's B2. Which is, okay, you're right, it's S2 minus F2, yes, you're right, okay? Because of that formula, right? That is the exact formula that defines what the basis risk is, right?
So when S2 equals F2, that's when the basis is.
Yes, that would be the case if you decide to go for, so if you have exactly a contract, a future contract expiring at time 2, at maturity F2 will be equal to S2, right? So F22 should be equal to S2. Okay? By the way, you have the opposite. I don't see why they are used. So the basis risk is symmetric with respect to the short and the buy, to the short and the long positions. You see, no special issue, and we are done. Okay. So this notion of basis risk for now is not very intuitive. With Marina, you will compute it in a very precise way by comparing the price of the future with the price of the forward. Okay? And we are now finally at the the nice, the easy part of this argument. That is now we are only left with the trading convention for the future. Okay? So what's the trading convention for the future? So assume you are two traders. One has a long position, one has the short position. Okay? So both deal with the broker, and the broker deals with the clearinghouse members. Okay?
What are clearinghouse members?
Sorry?
What are clearinghouse members?
So the clearinghouse members are those who grant the solvency of the clearinghouse, right? So usually it's a pool of banks, for example, that is supporting. So a clearinghouse is a financial intermediary, punchline, right? That is the one that intermediates between short and long positions, right? That matches them, okay? And clearinghouse members are, given that there is a high concentration of risk in this sector, so it's not possible that a single institution clears all the trades. So a pool of clearing members, so like a pool of banks, put the capital and help matching these orders. Okay? This is typical. When you have a high concentration of risk, you can diversify the risk by splitting across multiple members. Okay? Some terminology. Okay, so what is the open interest? Is the total number of contracts that have been opened and are not yet concluded. Okay? What's the settlement price? It's the price 1 second before the final auction is carried out. Okay? By the way, as I was saying, the settlement is daily. So every day there is, if you want, a reassessment of the value of these contracts. So this is the value added of having a future, that essentially once you know the dynamics for one day, you know the dynamics for the whole period, right? So because every contract, it is as if it was open in the morning and closed in the afternoon. This is the best way to understand what's going on with the future, okay? So to make, I don't want this example. Okay, this is my favorite example. Okay, so let's look at it. An investor takes a long position in gold futures contract on June 5. Each contract is 100 ounces of gold. So gold is now, on the hook. So futures price is 1,250. Initial margin requirement is, so you have to pay an initial margin and a maintenance margin when you enter in this position. What are these margins? These are the liquidity requirements that you have to use in order for the clearinghouse to accept you as a trading counterpart. Okay? You have an intermediary that is the broker, but in practice, you put some liquidity. The liquidity will be pulled in the clearinghouse, and this liquidity will be the one that grants the regularity of the flow of money. Okay? What do I mean by regularity? If somebody is not paying, the money coming from other counterparties will be used to replenish. Okay? By the way, you are diversifying. You want to diversify this risk. Okay? So you are creating a buffer of liquidity using these margins in order to keep a regular flow of transaction, even if sometimes some counterparty will fail to meet its obligations. This is the advantage that you get from centralizing the trade, right? That you can pool resources. So you have a requirement for each contract. You have to, you have these are two positions in two contracts. So each one requires 6,000. You have to put an initial margin of 12,000. The maintenance margin is 4,500. What is the maintenance margin? It is the minimum amount of money that you need to have in your margin account for you to continue trading. So for you to be accepted as a trading counterparty by the clearinghouse, okay, by the exchange. If you go below that threshold, they call you and say, okay, you have to replenish your margin. If you do not answer within a given time, you are taken out from the transactions, okay? And by the way, when you are taken out by a margin call, this means that you are losing money. So you are doing what you would not like to do. That is, you don't want to sell when the price is low, right? So your gain is to keep your position above the maintenance margin and hopefully increase the distance from the profit you are running from these operations. Okay? So let's see how the mechanics work. So assume that everything is moved, by the way, by the underlying price as capital T. Okay, so the information you have on the first column is exactly, okay, in the first column you have the trade price, so at day one, the price at which you enter. Okay, at day one, the settled price and the trade price should be the same, so you put simply the trade price, the settled price. Okay. Then you look at the movements, and you see, in the morning you set you have 1.250, but then in the afternoon the price goes down and you lose $9 per each ounce. Okay. So what happens because of your loss? Well, multiply by your standardized contracts. You see that you are losing 900 by 200, you get a loss of 1,800 position. This is the so-called leverage implicit in the position, right? So even if the price has moved by $9, because of the trading convention, you are trading two contracts, each one has a 100 positions, 100 ounces. This means that overall you are losing 1,800. Okay?
It's a 1 to 100 leverage then.
Yes, implicitly yes. Okay?
Yeah, because after all, the trade price is the price of 1 ounce, no?
Yes.
And
Yes.
you're-
Okay? Yes, you're right. Okay? The implicit leverage is good for the trader in terms of taking risk. It may be very bad if you lose, right?
yeah.
So this embedded or implicit leverage is an important incentive for people to take risk, putting a small amount of money, right? By the way, it's a good, but in order to use it in an appropriate way, you have to guarantee that you keep most of your capital safe and you only invest a small amount. Because you are taking a risk, you may take a lot of risk on a small position and that will be equivalent to take a little risk on a large position, right? Okay, so your margin balance, the original was 12,000, is reduced to 10,200, okay? But still you are above this 4,500. So nothing happens until you continue this trading for more days. What's the problem? That for each contract you must have a margin balance of at least 4,500. When you meet the 9,000 boundary, that is at day 6, you see. At day 6, you go below the 9,000.
Day 7.
You're right, sorry. Yeah, okay. Between day 6 and day 7, you hit a boundary, right? At day 7, you are below the boundary, right? This is when you get the margin call. You receive the margin call, sorry.
And you have to replenish until the initial margin requirement, because that's what
I thought it would be
here.
up to-
It's
I thought it would be
8,000, yes, you're right.
But I thought it would be the minimum, right? Like you have a minimum balance of 4,500. My assumption was, or my understanding at least, was that you need to put the money equivalent to at least the minimum.
So you can keep.
I know people usually keep a buffer just not to get another margin call next day.
Yes,
But I guess the legal requirement was to.
it would be enough.
Yeah.
You're right. So, good question. I don't know exactly. So, which is the margin, the request that you get from the margin call? Sorry about that. I should know that. So, here the guy is going to refill up to 12,000. In practice, for you to trade, most likely, I think there is a second boundary because it's very technical and it's different for different clearing houses, the convention. So if I remember, in the EMIR convention, there is a second threshold. You have to replenish at least up to this second threshold. In this case, it's this threshold is exactly equal to 6,000. Okay? So I think that sometimes there is an intermediate one. In this case, the minimum one where you have to replenish is exactly the original one, that is 6,000. Okay?
It makes sense because when you get to margin call, they don't want to call you every day.
Exactly. So you have okay. These are trading conventions, right? It depends. You have to look very carefully to the.
And can it happen that they don't call you, they just close the position?
Sorry?
Can it happen that they
No.
don't call you?
No. That that would be a crime. So it's something it's something that deals with the forensic finance, right?
That happens in retail, in retail investing a lot.
I have been assisting a customer that had to go through a legal action because at some point a stock exchange did a mistake in the regulation. They forbid the short selling position, say in the underlying, but not in a call, in the put and call. He made a lot of money, but the people were unhappy because essentially it was done money because of a mistake of the regulators. And people essentially forced the system in such a way that this guy lost most of the money. I assisted him. I'm not sure he could get back his money, unfortunately. So it's really what you name forensic finance. Okay. Now, what is important is that while you are losing, if you have a long position and you are losing, there will be another trader that has the short position that is getting the money. Okay. So how does the money accumulate? You see that in practice, it is your margin account that is the one where the money is accrued, right? So in practice, according to this example, if now at day 8 your margin account goes to 12,180, you have now a profit of 180 that you can take out while keeping your position open, right? So this is the way you mature immediately, every day, a loss or a benefit from your positions. Okay? Okay, I think we did everything we wanted. Okay, tax treatments, don't ask me, okay? Go to a fiscal account, go to an accountant.
The user knows. The user knows he's an accountant, bro.
Yes?
This guy.
Wow. He's the guy. So fiscal incentives are super important here. So what is, let me simply conclude with a preview of what is going to happen, the big challenge, that is the Black-Scholes puzzle. So what we learned from this tour de force on portfolios? We learned that if we simply stick to the low one price, same payoffs, same prices, and we are careful about long and short positions, we can run an exercise that applies whatever the future price, so a valuation exercise when we know the price FT at any date for a future contract, without having any information about the cost of equity or the cost of the risk capital, right? So everything we did in these two classes did not require any risk-return trade-off, risk adjustment, and so on and so forth, right? Yes?
In the case of futures contracts, is the same as in options, that the long position has unlimited loss? Because and the short position, the minimum is obviously zero, but it's sort of negative.
No, this is what we are going to discuss tomorrow. So, in this case, you have a right, but also an obligation. In fact, FT can go negative. There is no limited liability, right? So this is the major difference. In these contracts, you may have a positive or a negative price. There will be a loss because there is no limited liability. While on the option, as you were saying, there is a floor, so you have a right but not the obligation.
For short position, there's a floor.
Yes.
Floor, yeah.
So,
Yes?
you're going to explain that one? The stop loss is basically when you have the floor, right?
So Okay, we did not discuss so far the mechanics of the market order. So, okay, this type of orders do not apply to the futures. Okay, so this is, well, so let me delay, so I didn't intend to stop on this slide, sorry, this is for tomorrow. Let me conclude noting the problem, the open problem we have, okay? So the question mark is, how is this valuation approach, or is this valuation approach consistent with the CAPM? So, is Finance 2 consistent with the Finance 1 or not? So, how is it possible that we value a forward contract without having any information about the risk-return trade-off of the investors in this market?
Because we assume something about the risk-free rate, like the cash flow.
Great, this is the wording, right? It says you are risk neutral, but are people risk neutral?
No.
No. This was the situation before Black-Scholes. People knew that by playing with the law of one price and these things, you could come up with formulas that work without any reference to the risk adjustment, but they didn't really knew how to make this picture consistent with the picture of utility maximization and risk adjustment. Okay? This is going to be the topic we are going to discuss tomorrow. How to make the so-called risk neutral valuation, that is the extension of this argument into a more general type of derivatives, to make that approach consistent with the CAPM and Markowitz and all that. Okay? Great, thank you, and we'll see you tomorrow. Now you continue with Marina.
Buenos días. ¿La vais? Cañanes, que soy unos cañanes. Anán. ¿Qué?
¿No te importa el planeta?
No, la verdad es que me la suda todo el pino. Ah. Yes.
Yes, this is what we will cover tomorrow. Yes, this is exactly the step that is that are these APT notes that are already in the material, but it's the first step of it.
I thought that's the need for the information.
No. It's going to be, I thought I would have introduced today, but I want to spend more time on the mechanics, so, okay?
Quita Cristina. 1 minute.
Yeah. Enjoy the weather.
General, you will have, if you had more general, you would have, but it's finite, you would have the set of subsets. How many sets do you have here? So you count also the empty, it's 4. For instance, 1, 2, 3, 4. So it's 2 to the omega. But or 2 to the omega, 2, sorry. The number will be the number of elements of 2 to the omega will be what you would call 2 to the omega. You put the 2 bars to say the number of elements of omega. Okay? So to understand better what's going on, maybe I'll give you an exercise if you want simply to check that you understood that. do the same exercise, but instead of having two states, consider a two-step binomial tree, that is the one you're going to use with Marina. And you can construct F in that case. Okay? That is useful.
How is it?
Yes. So consider the recombining tree here, right?
Yeah.
So here you will have three states, maybe up, 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 down, down, up, and here you have down, down. Okay. So this one is a probability space. You have a sigma algebra. List the elements of the sigma algebra, of this sigma algebra. Okay? Of this algebra. In this case, it's not sigma, but it's algebra. Okay? Now, what's capital P? Capital P is the measure, the probability. So, what is important is that P is a function on F. So, in this case, we have two states. It's enough we give P of omega up, P of omega down, and we know all the P. But in general, do not forget that P is a function on the algebra, not on omega. Okay? So, what does P? How does P operate? P associates to an event its probability. Okay? The probability is a number that is between 0 and 1. It has some properties, arithmetic, and so on. In any case, because in this very special example, you will give P up and P down. This one, for normalization reasons, you can call this P and this one 1 minus P. Okay? Why I have to put P and 1 minus P? Because P of omega, the properties that you have to verify is that P. So if you give P up equal to small p, by normalization, P of down has to be 1 minus P. Okay? And by the way, P is a positive function. So in each event must have a non-negative probability. Okay? Let me say that. By the way, the choice of the probability, it's an important issue. It's maybe the most important issue. There are people, economists, that spend their whole life analyzing how people select P, their beliefs, okay, their expectations. And by far it's not unique the way you may choose P, okay? Econometrics is usually helping you, data science is helping you selecting a P, okay? Now, what we say so far here is saying that, if you want, another way of stating that result is saying that selecting the historical P, the one you can estimate from the historical prices, and using that P to price doesn't work. Okay, this is another way to state the result that we say. So no arbitrage seems to be inconsistent with historical assessment of probabilities. Okay. And why is this the case? Here it comes the contribution from the financial economics point of view. Okay? So Black and Scholes are the first to understand what's wrong in what we said so far. There is a logical gap, a logical problem, and we want to fix this problem now. Okay? So, the argument put forward by Black and Scholes is the so-called replication argument. Notice that this replication argument is not assuming anything about probabilities. Okay, this is the virtue of the replication argument. So we say, since we don't know how to choose P, for now we do not choose any P. Okay, We simply work without choosing a specific thing. Okay? We simply assume information on prices. So we have a 0 here. Here we have a 0 down. Here we have a 0 up. Up and down will be such that up is larger than 1 plus RF is larger than D. Recall that by A1 we have an RF, so in this case it will be a risk-free rate over a single period. So here we insist in using A.1 and A.2, so the two axioms. The first one is the existence of a cash account, the second is the law of one price. Okay? The state of nature described by the state of nature are described by the level of the underlying security, of the underlying price. So ideally, when we plot that plot, we are thinking here to have a continuum of prices. We have now moved in a Mickey Mouse space where we have only two possible outcomes to simplify the computation. Once we understand how the approach by Black-Scholes is working, we can go back and discuss the general case. Okay? So what's the argument of Black-Scholes? The argument of Black-Scholes is the argument of the investment banker. So let's move back to financial intermediation. What's the difference between an investment bank and a commercial bank?
Investment bank does transactions, no. Commercial bank lends money to people and companies.
Yes, why? What's structurally the difference? So Jesus is saying that the type of business run by a commercial bank and the type of business run by an investment bank is different. And while most of the profits is an interest rate margin for the commercial bank, that means they collect deposits, they extend loans. In the case of an investment bank, they collect intermediation fees because it's very expensive for them to extend loans. Why? They are not collecting deposits, right? That's the difference. So they don't have capital collected of people who are lending money to the bank. Okay? So the capital, so the money put at risk is very expensive for an investment bank because they don't have people that are putting their money in the cash account, in their cash account. Okay? So generally speaking, if you are an investment banker, you cannot take risk in the balance sheet. So in the balance sheet of an investment bank, ideally there should be no risk. Why? Because each time you raise the risk of the activities that you own, so assets minus liabilities, the more you rise this risk, the more charges you will have to pay because of the bank regulation, right? So the bank regulation is saying that if you want to rise the risk profile, so if you are lending money has at risk because there is a risk you don't get back your money. For that reason, you have to put some collateral, some reserves posted. You must freeze some amount of money in case somebody is not paying, right? It's like the margins for the CCP, okay? So for that reason, it's particularly expensive, for example, selling a call for an investment bank, right? Why? Because you are selling the call, so you are promising to repay something in the future, but on the other side, this promise is a risky promise because, for example, if the price you are selling a call and the price appreciates, you are exposed to the risk to pay a lot of money. Okay? So the problem faced by Black-Scholes is, okay, how can I craft a portfolio strategy for the bank such that I sell the call but I'm still simply cashing in the intermediation fee. I don't want to keep the risk of my call inside the balance sheet. So what you do is you simply sell the call and try to create a portfolio that removes the risk from your balance sheet. Okay? So this is the replication argument. The same. Okay, now I sell the call. I get today a price. Let's call it C0, right? But then what I do with this C0? If I simply keep this C0, that would might not be sufficient for me to repay the call payoff in the end to the customer. So I take out from this C0 some amount of money. I call this money, let's say, and but what can I do if I want to remove the risk from my balance sheet? Given that this is a derivative security, the only reasonable thing I can do is to buy the underlying, right? Because the risk of the derivative is correlated with the risk of the movement of the underlying, right? So the idea is that I create a portfolio where I have sold C0 and I buy something, I buy a number delta, which I want to determine, of underlying security at a price that it will be S0, correct?
Can you repeat the explanation of that's the variation of S0?
No. Delta is a number of shares. Sorry, you're right. So it's a conventional name, but it's a number of shares. Yes?
Could you repeat the replication argument, please? Like
Yes. So if I am an investment banker and I decide to sell the call and I get C0, I have a problem because I sold the call, today I get C0, but I'm promising to the counterparty to repay the payoff at maturity, correct? So in that case, within the balance sheet of the bank, you are holding the risk that comes from, for example, in the case of a call, the upside, the fact that in some states of nature you will have to repay a lot of money, much more than C0. Okay? So you get $2, and 1 year from now it might be the case that you have to pay 500. Okay? So it is true that as of today you simply got C0. But as a bank, you also know that there is this future risk, and so the regulators will ask you to put money frozen in your balance sheet to keep money, but this is very expensive for you because you don't have deposit, you don't have other people's money in your account. Okay? So the idea of Black-Scholes, or of Black, let's say, is that at least in this special situation of this Mickey Mouse and in other special situations, you can select delta in such a way, and C0, the price, set at C0 and delta, that are the two quantities you want to decide to compute, in such a way that in the future, whatever the outcome, you are, let's say, you are risk-free. Your portfolio is risk-free. Okay? So why we are now asking this portfolio to be risk-free? We are asking this portfolio to be risk-free because ideally the balance sheet of an investment bank has to be risk-free. Why? Because if the portfolio is risk-free, nobody will ask you to put capital as collateral. Okay? So out of all the portfolios you can create, it looks like strange, but for an investment bank, the best portfolio is the one that is free of any risk. Okay? So these banks are taking huge risk on each individual position, but the positions altogether must offset in such a way that the aggregate position is risk-free. Okay? So we try to do exactly that operation. Okay? So the idea is that now we take our Are you okay?
Yeah.
I don't understand.
Ah,
Like CO,
see,
you
this
buy
is.
or you sell?
Sorry? No, I get this one. I get.
You get it from,
Yes.
from your client.
Yeah, from my customer. I sell a call and I get the initial price.
Right.
That is C0. Therefore now I don't know what the amount is, but it is an amount.
Okay.
Then I take a fraction of this money, and with the fraction of this money, I buy a number delta of shares of the underlying, so the price will be delta S0. Okay? So overall, this is the amount of money which I still hold into my balance sheet, right? So if you want, you sell, so this is a liability of yours, right? This is the asset that you use to hedge that liability, to cover that liability. Correct? So you get the money, but you take a short position in the call. With the money you collect from the short position, you buy, you take a long position that you pay now delta is 0, and you have a long position in the underlying. Okay? This is the typical action taken from banks, insurers. When an insurer sells you a life insurance contract, it has immediately to go and do something to back the position, that is, they will buy fixed income securities, for example. Okay?
Okay. And when you say the underlying, what do you mean?
The security S0 is the one that, since now we are thinking of pricing a call, the underlying means the security underlying S0 that moves the price of the call. Okay?
Okay.
So the underlying security is the one described, the evolution of the value is the one described by this tree. Okay. Now I consider another tree for my portfolio. That is a portfolio that is also the balance sheet of the investment bank. Okay? So the value at time 0 is by construction C0 minus delta is 0. Which is the value of this portfolio at time 1? It will be the value of the call in the up state, right? So the value of the call in the up state will be S0 up minus K plus, right?
That's a D. Positive. Plus.
It's a plus.
So it's a plus, meaning only if the quantity is positive, right? Minus delta S up, S0 up, right? Correct? Here we have S0 down minus K positive part minus delta S0 down. Okay? So now we can take a numerical example to understand what's going on, right? So I take the case where stock price, initial stock price is 20. We can move to 22 or to 18. If I want to, for example, if I have a call option that is expiring in 3 months with a strike of 21, maybe the case that, you know, the stock price goes to 22, so the option is paying out 1, because it will be 22 minus 21 in the up state. In the down state, the price goes to 18, the strike is 21, the maximum between -3 and 0 is 0. Okay? So I'm repeating exactly the same argument, but you know, in the general case. Okay? So here this will be 1, this will be 0 in the case of the option. Now, what I want to do. So notice that. Are you okay?
Mm-hmm.
So now we apply the argument of the investment banker, right? So the argument of the investment banker is saying, well, what is my best choice for delta? The best choice for delta is the one such that there will be equally fine irrespective of the future price of S0. So I want to have a portfolio that is risk-free. What does risk-free mean in a binomial tree like this one? It simply means that whatever the outcome, you want to have the same amount of money, right? So, in this case, you want to put 22 delta, that is the value of your portfolio, minus 1, that is the amount you have to pay to go to the option buyer, equal to 18 delta, that is the value of your portfolio in case the final state is down. Okay? So, the delta you have to choose, you want to choose, is the one that equalizes across states the final payoff for your portfolio. Right? Because then you are a good investment banker. So an investment banker is somebody that wants to go home with a clean table, right? Or with an empty table. So you don't want to wait during the night for something, hoping for the best. Okay? Which is equivalent to say that you want to have the balance sheet of the bank cleared whatever the outcome. Okay? So notice that so far, no probabilities. Okay? So no role for the probabilities. And now we understand why it's reasonable to have an argument, as in the case of a forward, that is free from probabilities. Because if you're an investment banker, you don't want that your cash flows depend on the future outcomes. You are not an asset manager spending heavy or a lender, right? You want to simply get a fee, the fee for your service. The service is creating the option and selling the option. But the fee does not depend on the effective outcome in the market. Okay? So, in the case with the numbers, it's pretty easy. You get that delta has to be equal to 0.25. This means that essentially for each call contract, you have to buy 1/4 underlying shares. So if you want, so 1 share of equity will cover 4 call contracts. Okay? Now we need to do the same computation in this case here. All right? So we want to put this one equal to this one.
So you need that the price, that the SO up is equal to SO down, no?
No?
Because the rest of the equation isn't the same.
No, it is not, right? Because you have this non-linearity, right?
Yeah.
No, it is not a linear equation, this one, you see? Okay. So, what's the delta you should choose? So, call this quantity CU and call this quantity CD, right? Because this will be the payoffs for the call in the up state and the down state, okay? So if you put that CU minus delta S0U has to be equal to CD minus delta S0 TE, you get that CU minus CD has to be equal to delta S0 U minus S0 D, right? So the delta, this is what you name the delta Black-Scholes because it is selected according to the Black-Scholes criterion, is the one where you have C up minus C down over S0 up minus S0 down, okay? So if you think about the geometric, or you know, the intuition, the intuitive notion here, what's the notion? The notion is that you are analyzing how you have to buy an amount that is the finite difference derivative, so it's a variation in the price of the call across the states divided by the price of the underlying across states, okay?
It's like an elasticity, bro.
It's not so. It's a first order difference. The elasticity would require you to multiply by S and divide by C, and then you would have it's closer to elasticity, but it's not exactly an elasticity. Okay, it's a first order difference. Okay. So what you discover, and this is the most important discovery, is that you have a smart way to select a position in the underlying, your assets, such that whatever the outcome, the value of your portfolio is the same. Okay?
What's the reason to recall both formulas?
You are an investment banker. You don't want your money, the money you have in the end, depend on the state of nature which is realized. So the only way is that to set the two equal, right? Correct? You understand? So if you are
We don't offer the option.
The state of nature is being written.
It doesn't matter what happens.
So essentially, the idea is that once you end to, so you get C0 at the beginning. You put delta, selected in this way, into S. You don't care what's going to happen in the future because what's it's a hedge. Okay. Okay. Very good. So now we have a recipe for our Black-Scholes delta. So notice that this is delta is a solution to a linear system now, given the prices of these contracts, right? So now we plug back. So if we plug delta Black-Scholes into the original expression here, and here, okay, so you will have C0 minus delta S0 as the value of your portfolio at time 0. You will have at time 1, this value is the same across the states for your portfolio. Okay? So, for example, let's take state up. So you will have C up minus delta Black-Scholes by S0 U. This quantity will be equal to C up minus C down over S0 up minus S0 down by S0 up. Okay, this is the money you get at time 1. You divide this by the money you are spending at time 0. Well, let's write it better for people. Okay?
So the value we get here is what investment banks are willing to pay in order to mitigate risk.
Yes. No. This quantity here will be the value of the portfolio. This is the value of the portfolio at time one for the, this is, if you want, this is the balance sheet of the investment bank at time one. So let's call it, balance sheet time one, divided the balance sheet at time 0. Okay?
That's why you use C0.
Sorry? You don't know, we still don't know C0, right?
Yeah, but that's why the formula is C0, no? It's not any other thing. It's the value at the beginning.
Yes. Okay, so now BS1 over BS0 is the rate of return, is the total return, correct, for the balance sheet of the bank. Because if you invest BS0 into this portfolio, at time 1 you will get BS1. Okay? So BS1 over BS0 is the total return earned by somebody who is investing in this portfolio, that is in practice the balance sheet of the investment bank. Okay? Now I ask you, what's the only, here we use A2, the absence of arbitrage opportunities, which is the only value of this rate of return that is consistent with no arbitrage.
Which is the what profit?
Which is the expected rate of return I should earn if I invest in this BS?
Yeah, which we make.
Must be the risk-free rate. Yes, why? Because we are risk-free. We are investing in a risk-free portfolio because we selected Delta in order for this to be a risk-free portfolio. We have another security that is risk-free by A1. If we had that the rate of return on this portfolio is higher than RF, there would be arbitrage. So for no arbitrage to hold, this rate of return has to be equal to 1 plus RF. Okay? And so now, essentially, why this step is important? Because now in this equation we know everything but C0. So now we explicit this equation in C0, and we get, out of this equation, we get the price of the call, the fair price of the call. Okay? And we have been deriving everything without any reference to any probability. Okay? Okay. Is it okay?
Yeah, we're saying that at the beginning, in the numeric equation, in the numerator is CU minus CD over, like the first part is CU.
Here is CU.
Yes, exactly.
Here is a zero.
It's CU.
I might choose also a D, right? Nothing will change, right?
Yeah,
If I was choosing CD and D, nothing
it's not important. This is only the ratio between the average scenario and the previous.
The ratio between the future scenario, once I have selected delta in such a way that it is equal across.
Yeah, because it's gonna be the same.
Exactly.
It's gonna be the same. That's right.
It's gonna be the same. Okay?
Right.
So now I bring on the left this quantity, so I now have C0 minus C up minus C down over A0 up minus A0 down by A0 up. This is equal to okay, I have to multiply by 1/2 plus RF here, and this has to be equal to
CU minus
CU minus CD over S0U minus S0D by S0U, right? Okay. Very good. So it's a bit involved as a computation, but it's very instructive, so it's worth doing it.
Take the break.
Yes. So, do you prefer me to finish the computation and take a break?
Yes, please.
Okay. So it's very easy. It's simply algebra now. Okay.
Okay. Basically, C0 equal the thing on the right over 1 plus RF plus CU.
Exactly. So we do this. Now I keep on the left C0. That is the quantity I don't know. I bring everything else to the right. And so now I have that C0 by 1 plus RF has to be equal to. And now I bring on the right and I will have something like, CU minus
So no C0 times 1 plus RF is equal to CU.
CU minus CD. And let me do a computation this way. CU minus CD, S0U minus S0D. I collect this quantity and then I have 1 plus RF by S0U by this term here, right? Minus S0U, right?
Yeah.
So this one and this one cancel, and I'm left with direct S0U, correct? Okay. Then notice that I can drop the S0 here, the S0 here, the S0 here, right?
Having 6.
Okay, so now I'm left with C0, 1 plus RF, and here I have this CU. Okay, now what I want to do, I want to split two contributions, one proportional to CU, one proportional to CD. Okay? So the contribution to CU will be 1 from this one minus, then I have CU here, so here we have 1 minus up minus down, and on top I will have RF minus U, right? I have to invert because there is this minus. Here I have CU, here I have up minus down. Okay, then I have plus CD No, it's correct. So, and here I have up minus down, and here I have RF minus U, right? So there is only a minor issue, right? Because okay. So if I add D instead of up, it would be okay, right? Why did why did I get
You are separating the contribution
of the up state and the down state, right? I should be correct if I here I have D. Instead I have U.
Huh?
So this is the final formula,
Yeah.
right? So now, notice that I can call this quantity, I can call this quantity pi. Okay? If I call this quantity pi, yes. Then you have the 1 plus RF and you get finally the C0 is a discounted expectation. That is what I wanted to prove. The only problem is that for some reason I should have D not here. So let me check. No, it's so it's 0 minus U minus D S0 U minus S0 D S0 U and that's okay. Here I have CU minus U minus.
Well, I think that's the RF minus U. What does it come from? Because technically it's multiplying RF times U.
No, you're right. It's, I did a wrong computation here, right? Because it's 1 plus RF multiplied by S0U here.
Exactly, it's multiplying.
So, yes, so it's a mistake here, sorry. Okay? So, I wanted to go to the coffee too fast. So, I have to go to CU minus CD over S0U minus S0D, and then here you have
URF.
URF, and that's okay. Okay.
1 plus RF.
So 1 plus RF, 0U minus the 0U, the 1 goes away.
I was asking this one, right? That's a 1 plus RF, bro.
Sorry?
That's a 1 plus RF, right?
What? No, it's U pi RF.
This pi RF.
Yes. Okay.
What's this? Pi times RF?
No, it's U by RF.
Oh, it's
It's RF by U. And then, okay, sorry. Okay? Okay. Okay, now I have to connect the CU, so I get CU by 1 minus, and here you have 1 U minus D
Times
times RF by U, right?
plus
Plus
CD
CD, and here you have RF by U over
U minus D.
U minus D. Now, if I here I should get RF minus D, and then you
RF minus D.
Yes, I think. Let's see. Well, I think there is a computation here. Okay. So here we are. Okay. So F is equal to S0 delta.
What is it here?
Sorry?
F here is still the
F is the value of the call for us. No, you know, I saw, you see there is a mistake here. So it's not a 0 U, it's a 0 because it's a times 0 this one.
S0 period.
And so, at times 0, the value of microphone is 0 minus delta is 0.
Yeah, so in the denominator we don't.
So this U is not appealing.
Okay. Yeah, the problem is that you.
So here it's not U. Okay. Good. So this is not U. So here it is not simplified, right? You have 1 plus RF. So it's 1 plus RF is 0 minus 0 U. Okay? Because I brought this.
Yeah.
Okay? Now S0 simplifies, and now I'm left with, here I have.
Now it's RF minus 2.
And then, okay. So now,
Because you have to remove the 1.
no, I don't, I cannot remove any.
Yeah.
Okay? So, okay, there was the mistake. I tried to remove the 1 by the characters, right? So here you get 1 plus RF minus D minus U divided by up minus down. Okay? And this is correct now. It is correct because notice that this quantity here can be written like in this way. I add and delete, so.
But in the parentheses you should have U minus D in the denominator, no? In the parentheses you don't have denominator.
Yes, but okay, you're right. Okay, good. Correct. Okay. And now finally it's correct. So the trick is the following. Take this one, 1 plus RF minus U, then add the D and subtract the D, and this is remaining the same. Okay? So now you see that this quantity is going to be equal to 1 plus RF minus D over up minus D minus 1. Okay? So now set this quantity here equal to pi. I call this pi as a probability. Because you see it's 1 plus RF minus D is positive. U minus D is positive and U is larger than 1 plus RF. So pi, defined this way, pi, I define it like 1 plus RF minus B over up and minus down. This quantity is larger than 0, is smaller than 1. Okay? It is larger than 0 because 1 plus RF must be larger than D. It is more than 1 because 1 plus RF must be smaller than U. Okay? So pi is a number that I can associate to a probability. Okay? So now I go back here, and this quantity can be written as pi minus 1. Okay, now we are there. Now notice that here I have a minus, so I can take this to plus, and this will become 1 minus pi. Okay, so now I have Cu plus Cu minus Cd multiplied by 1 minus pi. Okay? And so finally, I have that this one, I collect Cu, will be Cu by 1 so it's Cu 1 minus pi, 1 minus pi, so it's u minus u pi minus 1. No, it's u by pi.
Exactly. Cu times 1 minus 1 minus pi.
Yes, which is pi plus CD by 1 minus pi. And so overall I have that C0 1 plus RF is equal to this weighted average. Okay?
Shouldn't be minus CD.
Yes, no, it's plus CD by 1 minus pi. Here is pi minus 1.
Yeah, but look below.
This is minus,
Look below there because you swap the sign.
Yeah,
should be minus here, you should say. So there is a sign mistake, it should be plus. I think it's better we take the break.
Okay.
So and then we do the computation slowly. So everything is okay, but we need to take algebra.
Just the minus.
Okay, sorry.
It's a negative times negative, which makes CD positive like
Yes. So it should be positive. It should be positive. You're right. So it is correct. It's positive. So it does. Yeah, minus here and minus here. So it's positive. It's correct.
Yeah, but the problem is that you have to swap one of the signs to make 1 minus 5.
yeah, the first thing is the negative. Is Cu plus Cu minus CD.
So let me check. It's 1 minus u. You're right. There is
There is a problem there.
there is a problem with this sign. Okay.
Yeah.
Now take a break and then we.
Yeah,
I will do the full.
Let's check it later.
Yes.
Está clarísimo.
Está claro. No, es que lo mira muy bien. Muchas cosas. Mucha implicación. ¿Qué? Llegas ahí.
No, no sé si tenía pegado con otra vez.
Un poco más. Y la matemática de juego. Sí, ya está más rápido y también lo probable.
Into de joya.
Ya, tú, que.
Bueno, vamos. Tocar algo. Tocar algo.
Que al final todo entero.
Te querías muy listo. No, bien. A mí me vas con los cosines. ¡Ojo! No me pierda, venga. ¿Qué de Cuaresma? ¿Qué de Cuaresma? Mira. ¿Tienes algo? ¿O salimos fuera? Ya, pero
Hi.
Nada. I was going to say something, but...
You have a beautiful job. You never for that much in your shoes.
Yes, maybe.
Shoes. My biggest business. I'm ever my bullshit. It's usually bullshit.
BS1 over BS1.
So BS1 at period 1 and then at time 0.
Of what?
Of what?
Remember at time 1 of what? Like, what at time 1?
Like the price. Because remember ni C0, CU, ikikuwa juu, and then C0 ikikuwa hapa. I hope I'm not lying. Like, so you see the upwards and then at time 0. So BS1 is when it's up and then at time 0.
Okay, green.
I solved it.
You did?
Found the
I don't understand why this binomial is this hard. It should not be, it shouldn't be this hard. It's a simple thing. No,
I have to answer you.
Because
I have to
the problem is
to the
this
message.
presentation and the way it's explaining it is problematic. Because I remember doing this and I remember being really good at it.
Have you
Like
found
proving
the
that
solution?
the price of a call is
Are you
this.
going to do the welcome? Yeah. Box. Rural box.
What do you mean?
Box. Come. Oh. It's rural.
I'm not sure it's the one percent full na hapa mregister class. So when I said before alikuwa anapiga picha.
What was it?
Alikuwa she was taking photos and then she sent to me. He proved that she was in class. Let me show you.
But you do them just
Yeah. She had a problem with the registration, so she used to take selfies with me.
Really?
You see?
That's why you have the
She sent
photo?
me an email.
Oh, really?
To prove that she was in class.
Tell me that she was in class.
And have you taken,
Yeah, this is, yeah.
because in,
No, these are derivative options. Anyway, so I saw this email, I was like, I have to start. This
that's weird. Why? Because you make notes about.
because of attendance.
So
There's attendance register which people need to sign.
But it does go.
Yes. You can't do the exam if you don't.
Really?
You need to at least attend 67%. Two-thirds.
Really?
So you need
Here is fine. It's unless the professor is.
So it's your body problem.
Yeah. You have to go.
But now we're ready.
Look at it.
Yeah. No, but even
Really? It's up to
even
you.
in degree, even in your
The
undergrad.
machine, I don't think the machine has
Yeah.
No, that was you have to
Okay.
What do you mean?
Does the vending machine just offer me? Like, just me?
No. Maybe at the cafeteria.
Unless you go to the library and then they give you a shot of milk. Like this.
But you want just me?
For 2 euros. And hot water. You can use to iron your clothes. That thing is very hot. So they give you water, this big, and then a shot of milk.
Why?
I don't know.
That is if you ask for milk.
I asked for tea. I was given that without tea. and it's not because of language barrier, and because it was somebody asking for it for me. Like, it was not me who said it.
Maybe the hot water was not tea.
No, I thought it would be strong tea. And then I put in the milk. Na hiyo container ni ile ya chuma. Ni water. 2.8 and I buy 1 liter of milk at 1 point something, it was 1.11. I was like, I can bring these guys milk and then I take it slowly. After wamenipatia, inataka ninunue maziwa, niwaletee, alafu nachukua hapo. Oh, ningebeba maziwa nikupatia. Malaysia, I feel we know these people.
No, I'm not going I like that too.
I think it's.
Alikuwa anaongelesha wanawake.
No,
Ndio maana nikuletea mtu conversation yako. Mbona
no, niliwatch kitambo.
Sir,
So jana nilikuwa
I feel like that word, especially in our culture, is given too much importance. Like
This
it's
is
given
not just now.
It's not a view actually. It's okay. It's a matter of being able to express yourself.
Do you remember the
Yeah,
word?
wanaume lazima wajiexpress.
Right.
Wanaume wasipojiexpress.
Can you tell me
No,
like,
you
like
wanaume
one
wanapokuuliza
that you
kama
mean
huwezi jiexpress, unajibu
English and
sana.
Swahili or
You should be able to express
Albeit.
yourself. Now,
Albeit.
okay, the connotations that that word has for me.
Just English? Yeah.
Tunafaa
Really?
You thought I put something maybe one in
watu
Kama kuambiana ama wasichana wanafanya hivyo kwa time.
Sure,
It's
it's not a masculine thing, but kwa
Ndio
mimi
nataka pia na Mungu wanaona.
it's not a masculine thing. It's not a masculine thing.
No.
That doesn't mean embracing the femininity.
It's a-
It's true.
It should be masculine.
Yeah.
And
And
it's
they should
because
be
it's
feminine.
for
And it's
formal
okay
or
to
what?
be masculine. What is it of young
First time, like even
It's like
Mbona tuambie
all
usihari
the
sana.
English.
Tunaambiana kila wakati. Usifanye nguo, usifanye hivi, usifanye hivi.
Which is wrong. All the things you unataka.
No, Simon Sinek was saying it.
you have
Hey,
to
hapa
be-
na-
No, respond to political news.
No, I want to show you the first
I read old books.
Where does it come from?
It's actually tough. Alishangaa, wait.
No, it was his moment of weakness.
Okay, sasa nimeanza kutafuta videos.
Matilda, Matilda, lazima nikwambie nakupenda ndio nakupenda.
No.
It's true, si lazima.
Si lazima.
But
Hiyo ni
unaweza
because
like
actions speak louder.
So nitabidi wasichana kufanyanga hivyo.
Hapana.
Na sawa. Nitabidi wasichana.
Hapana.
I know that obviously
Kujirepress emotionally ndio huwezi express.
Si
Na hizi
kujirepress.
ili kujirepress ndio hauwezi sema like
Hapana.
you can only like
We don't just do it as
Yes,
men.
that's
Tuseme
like
Simple.
right in here, they go up, they go low, and I was like, no.
Kuangalia
Wengi sana.
wewe unataka mtu yake anampenda.
wengi sana.
Yeah. But
Sasa,
they can't
ngoja
get,
nikwambie.
they can't get enough. You know, like,
Mimi nimeona
Aje.
aggressive.
Yes, ndio. Exactly.
mimi nimeona nataka kusofia kwa position yake sasa. Anaanza kuambia I love you na mtu yake. What do you mean? Why? Sikia.
Akimweza kuambia wewe kama kijana yake, hizi anaambia maboys wote huko wanashika bia.
Hiyo kwa sasa hivi. But sikia.
Lakini wasichana wanaambia kila siku gani, muda uko 50 unaona iwasha. Wanajiita gani? Uko 45.
The reason nasema like
Kwa wanawake, hawezi pata wanaume tu wametengeneza uniform,
Hiyo ni
wanaenda
kweli,
naivasha.
itakuwa
kuna wale wanaona hivyo. We want to love you but really.
These people they want to make women
Effeminate.
Eh?
like a princess.
What are you talking about?
We were saying that he should be able to express his emotions through it. Like if he loves something, he loves it. If he says it, and he can say I love it.
No, because
I would
it's
say,
the law
was just
masculinity.
what say what
Yes,
Some people
And
Nini?
he is the law.
Yeah, that's why I keep it. Really, what? When you push it out.
And why have you talked about that?
We were discussing yesterday. I don't know.
No, it's a problem because you know that the usually the ones who go into the alcohol are the men.
Yeah, because they can't express
They
themselves.
don't know how to manage the issue, so they just go to. I mean, yeah.
against me from it.
I told you that I love you. It is like Oh, we were discussing that emotions are complex. Yeah.
The what?
That's why that happened. And I was like, they're not, but we are the complex people. We take those emotions and put them in different things.
My point is just let women be women. Let women be women and men. What is it?
Yeah.
It's
Because-
let a
because-
person be the person.
But
they are.
do you
No, 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 no.
It
Because
is
if,
women who are also not
if,
expressive.
if a lady comes to me crying, I should tell her,
what?
if a lady comes to me crying, I can't tell them to man.
And you shouldn't
man.
tell a man either.
No, for some things they need to stop.
No,
To
but
man.
To be a man.
crying is an expression.
Like when you
If it's
cry.
from
They
a
should be able to
It's
express
expressive for me.
themselves.
Okay, I cried last week when I went for lunch.
But this is
And it was okay. You didn't take it fine
would you tell a friend like be a man?
For some things, I won't say direct, but this is greatness.
He look at you and
But be a man, no try to no, like be a man.
I have a friend.
You know,
I have a friend. His younger brother was crying. I don't know what. We do something serious.
That's a problem because if you don't let the people cry,
And it was the family. And he told me
it's stuck inside you. I mean,
Okay.
or he or
for the same amount of problem, holding my heart was constant. I would treat a very different from the way I treat a man.
my problem with saying treating them differently is okay, but the problem with telling a person to be a man about something is almost equivalent to don't be a woman about something.
No,
Like what?
Yeah,
Yeah.
because you're saying
no.
yeah,
what
no,
is not a
why-
man is a woman.
Why-
So
why is
you're
man a-
telling them
I'm just telling them to be. I'm asking.
no, but no.
Yeah, so
She has a-
being not being
Exactly,
masculine
so-
is being feminine.
And you have associated that thing to a negative connotation because you have said that you shouldn't do this because you're a man.
Yes.
So
think about that. Think about like no, I mean,
You think of what
you should tell them you should listen as you would a woman, but maybe from a different connotation. Yeah, if you would have a woman, maybe take the time to someone not to express themselves. Like you can deal with it differently. But how you perceive
why you say like
Pero luego hay una zona y ese güey se anda por
Ah,
ahí.
ah, no,
Ay,
but for me, I work
en una
with
sala.
Una televisión.
No, but I
¿Por qué no quiero? Es más fácil
Es más fácil que estar con Salimina.
Hola, tú ya tienes horas con la matemática.
Un contrato millonario. Y automáticamente y le has pasado juego.
but if you want, I don't get it.
we work.
Okay.
Why not?
I know.
Shadrach was. I actually was the same exact necklace that he wears.
Okay.
Because I saw it on him. I think it's cute. It's acceptable. It's alright.
Cóbrame el alquiler del
No, no te preocupes, eso no lo pago.
Bueno, mi bueno te va a pasar.
Yeah.
Sí, sí.
Vuelven a notar los días en mi lugar. ¿Dónde están?
Y de compañía.
Ya estoy venido y lo están
Sí, ok.
Okay, so finally it was a really minor mistake. So let's check whether it goes. I wrote it. Okay, so now here there is no U. This was the first mistake, right? So it's simply S0, no S0U. Okay, this is we already verified, right? And now this is the computation. So now I keep C0, 1 plus or F on the left, and I bring on the right this quantity. And here I have a plus because the 1 plus or F has a minus, but then I bring it onto the right, and then here in my must put a plus, not a minus. Okay? Then here I simplify the S0, and then I add and take out the D, and so I get a pi minus 1. This was exactly the same we did before, but here I have a plus now. Okay?
Yeah.
Now I split in two contributions. One contribution is C1, Cu, 1 plus pi minus 1, that is pi.
Yeah, now it makes sense.
And now, then I have minus CD by pi minus 1, that is equal to 1 minus pi by CD.
Exactly.
Okay? And now everything goes through. And now I divide everything by 1 over 1 plus RF. And what I get is a formula that says that C0, right, is the discounted expectation. This is an expectation. But now notice that the pi, the probability that I'm using, is not the historical one. It's one that is simply determined by that formula. So my pi here is the one that is usually named risk neutral probability. Its expression is pi is equal to 1 plus RF minus D over up minus down. Okay? So notice that here, up and down are the increase or decrease in price between time 0 and time 1 in the two states of nature. So now I'm using a completely different way of setting the probability. I set the probability based on prices, right? Depending on the change in the underlying price when in the up scenario, in the down scenario, I set a probability pi that is defined in that way. So the probability pi is an output of an assessment about the prices. Okay? This is a very, if you want, this is very important. That generally speaking, this is a fact that is true in general in the general financial economics. When you think about a probability, you should think about it like a price. In particular, in the definition of definiti, that was a famous decision theorist, what is the probability that you assign to an event? Is the amount of money, assume you have 100 euros or 100%, an amount of money normalized to 1. The probability of an event is the amount of money out of this 1 that you are willing to bet on that outcome. Okay, so essentially, if you think that the probability of success is 60%, this means that out of 1, you are accepting to pay 0.6 on the favorable bet, on the bet winning if that event takes place. Okay? So, according to this approach, I set pi in this way, and finally I have a formula where I discount the risk-free, the cash flow, that in this case will be ST minus K plus, and I have my initial price, right?
What is the expectation? Sorry, could you repeat?
Yes. So when I take this expectation, using the probability pi, in order to recall that this is not the historical probability, I use a Q because this is the standard notation. Q stands for risk neutral probability. Okay?
Yeah.
So that is the Blackboard letter. It's it's a Q in the part. Okay? Okay? Very good.
the code today is the expected value of the difference, the positive difference between the stock price at time T and the strike price discounted at risk-free rate. No?
Yes, but the key point is that you cannot discount with this probability, the historical one. So you cannot compute the expectation using the historical.
Okay.
You have to use that specific recipe. If you want, that recipe is the recipe that is selected by the investment banker when he or she sets the condition that you want to get money without taking risk. This is why you discounted the risk.
So the Q, we find the Q with this formula basically is the risk-free equivalent when you have the stock and the call options, right? Options.
Yes, yes. So then why you discounted the risk-free? Now we understand why you are discounting the risk-free. Because you never discount in this exercise a risky amount. You always first hedge. You remove the risk from your portfolio. Once you have removed the risk from your portfolio, it's correct to discount the risk-free, right?
Can we want a mini example, like the ones in the slides of these?
Sure. No, it's we went through it. It was
the same as the previous exercise.
It's exactly the same. So, okay, you will look later examples. This will be in your today, tomorrow. You will spend a lot of time pricing in this way, okay? With Marina. So you see, this is the full derivation. Okay, this is the example. You compute the P. Now, okay, so sorry about that. So I really hate that. But, this is poor guy, John Hart, I love the book, but I don't like that he's calling P the probability. Because then it seems that this probability P is the one you typically use. On the contrary, you have always to remember that to discount at the risk-free rate, you have to change the probabilities. So you have to set the probabilities according to this very special rule that is the investment banker rule. Okay?
P here is Q.
It's what they call pi, right? To avoid any, and most of the people would like to call it Q. Okay? So the 0.5543 is not the historical probability of having an upstate. That is completely unrelated, right?
How would you define in simple words the residual probability approach?
This is what we are going to discuss now. Okay. First of all, we know how to compute it, and now we are exactly wondering how the hell this Q or pi is related with P. Okay? So, what's the role of this object? At the moment, I want to stress that this is simply, if you want, a trick to write the price as an expectation. Okay? So the existence of this Q is very important because it is telling us that we can keep working with no arbitrage principle and the relationship where we discount that there is free on one side, and on the other side we keep working with expectations. Okay? But these have to be, now what I realize is that I can use this formula, but this formula cannot be used with the P here. If I want to put here, as I should, a ref, here I have to put a Q, not a P. Okay? So what I learned from this exercise is that I want A and B all together. Then I have a way to express my price as a conditional expectation, as an expectation. I discount that there is P. The cost I have to pay is that here there is not an arbitrary probability, there is the risk neutral one. Okay? Okay?
Can you repeat that again? There is no arbitrage opportunity.
So I want to keep absence of arbitrage opportunities, existence of a risk-free cash account. I want to keep that, I want to use an expectation to express my price. So if I want to have an expectation and discount and be consistent with the no arbitrage, then the formula I can use is this one that I derived there, where I discount as a risk-free and I use a specific probability Q that is the one computed according to that rule. Okay?
That's probability Euler. That is the left of the probability Euler equals.
Sorry?
That
Price of
No, it's price this one. It's the
okay.
price of the call this one. Let me write price. So
the price of the call is not the same as C0, bro.
you're right. Well, yes. You're not here. I was.
Okay, yeah.
Okay. And by the way, this is not special to the code, right? You could repeat exactly the same argument by changing. Here we use CU and CD. By changing CU and CD, you can price any contract. Okay? Now, so what I want to stress is that for now we are using pi, we are calling it probability, but for us, it could be simply called a number between 0 and 1, right? Normalized and so on, because at the moment we don't have any statistical information that makes contact with this pi. Okay? So what we know for sure is that this pi is not going to be the historical one. Okay? So the question we need to address now from a practical point of view is, how do I get information about this pi and how should I use it? For example, a friend of mine that then went to jail, not a friend, a person I know, let's say it this way. It's not my friend, it's a test of the person the most the person I know that are my friends, right? No, the guy was
To jail, I thought he went to jail at the university.
no,
He went to jail.
no, the guy, he's, the name of the guy is, so, the name of the guy is, he was a commissioner in the stock exchange commission. Apparently he was a nice guy, he was coming to the conferences, giving great talks about option pricing and so on. Then he became the head of, okay, it's the similar, it's like the Trump's police, but the Italian one. So what's the name? So what's this police for the IC? Okay, it's the Italian IC. He became the head of for a political, he went into politics.
Yeah.
He became the head of this IC like, it was trade IC. So it was like police but for trade, controlling the boundaries for trade.
The SEC. Like the
Security change.
No, for the trade of physical goods at the boundaries. So it's called Agenzia delle Dogane. How do you call the boundaries? The Dogane, right? So it's Dogana is when you are checked, screened, because you are passing
border
control, trade border control, something like that, okay? And then the guy started using the money of this trade border control to buy a Lamborghini and so on. And then to have a nice meetings with some administrative stuff there, and finally finished to jail. So that's why.
good guy. He had a good taste at least.
That's true.
And also, there are things we can learn, not to do them, but things we can learn.
Okay. So, this guy, while he was at the Italian SEC, he originally was a member of the Italian SEC.
He was a financier, this guy.
He had a master like yours, Valente Curato. He came back and he got this position at the Italian also.
An expert in finance like us.
Well, no, you should be better than him. For this reason. That so when you issue a new financial product, by the regulation, by MiFID regulation, you are forced to issue some material, some information. It's called the information sheet or something like that, right? So it's a couple of pages where you describe the product and the way that product may produce profits or losses. Okay? Now my question is the following. Assume that you want to issue a call and you have to give this information to people. So you have to describe the statistical distribution of returns for a financial product. And you want to give this information to people outside. Should you give this information under P or under Q? So should you give the statistical distribution, and in this case would be either pi or let's call it P, another for the historical probability. So should you give to people this information or this one?
Pi, no.
The second.
No. Why? So it depends who should know pi and who should know P, let's say. Pi is the risk neutral. P is this one, the one where you simply give the historical probability of going up or going down. Both are relevant. So do not forget that both the historical probability and the risk neutral are relevant.
The historical probability is for when you want to sell, like for the potential buyers.
So you have to go back and think about the origin of this pi. If you are an investment banker, do you care about the probability of going up or down? You don't. Why? This is the type of question you should get to the exam, so it's important to try to answer. So I tell you why an investment banker does not have a lot of interest on this probability. So the historical probability for the price to appreciate at 20%.
Because they have already covered the risk.
You know, his wage is not, or her wage is not going to be dependent on that P, right? Because the portfolio of an investment banker will simply make money out of eventually, instead of charging a price C0, they will charge C0 plus an premium, an intermediation fee. So the profit for an investment banker does not depend on whether the price is going up or down. This is a problem of the customer, not of the investment banker, right? So pi is relevant for all those people whose future does not depend on the future market outcomes. And there are a lot of people like that in the market that are simply intermediating. They don't want to take risk, okay? On the contrary, if you are the final buyer or the risk manager of a company that is willing to invest using these products, that is a completely different story, right?
Yeah.
Because in that case, you want to know what's the probability of a very bad or a very good outcome. Because that will affect your payoff and your wage, okay? So each time you need to decide whether you should give a pi or a P. So think about real people, don't think about mathematics, okay? So this risk neutral, let's call it technology, is a little bit misleading because it's giving you the power to set up nice formulas, but these formulas are only good as they are for the investment bankers that have the huge machinery that is hedging. As I was mentioning, if you take the forward, the future, and so on, like the Marinas example, okay? So I have been consulting for a corporation, a steel producer, that almost defaulted because they took they wanted to hedge the risk on foreign exchange rates, and they took swaps, and these swaps, you know, there was a movement in the exchange rate that was against, and they needed liquidity for the margin call, and they didn't have the liquidity, okay? So essentially, only banks and investment banks in particular have such a heavy liquidity capacity, or also management capacity, to keep their position fully hedged, okay? And only if you are assuming that you are fully hedging your position, your price and your values will be will be given properly by this formula. In case, on the contrary, you are interested in the future outcomes, now it takes a little bit more work to understand how to relate these quantities with the original historical probabilities. Okay? So Black and Scholes were brilliant because they were able to solve the paradox of saying, okay, I want an expectation, I want no arbitrage. Well, the investment banker can do it easily, okay, because it will discount, he will or she will discount at risk-free by using these instruments that we call risk-neutral probabilities. Why we call these probabilities risk-neutral? Going back to the computation of yesterday.
It's because it is based on the risk-free.
So let's apply that formula to the underlying. And this will apply, right? So if I take the price today of the underlying, according to this measure, this will be 1 over 1 plus RF, expected value in the future under Q of what? Of S capital T, right? Correct? So this expression is telling you that if you are you have no arbitrage, you have assumptions verified. Under this measure, the best expectation of the future price is the current price capitalized at the risk-free, which is what you would call the forward price, right? So this is F capital T. Right.
On the expression.
Okay. So F capital T will be a 0 capitalized 1 plus R. Okay. So now we realize that Q is very special because essentially your expectation is in line with the future trading, and this has to be because of the no arbitrage constraint. But now, what we also realize is that this approach is saying something that, from a practical point of view, is exactly the statement we do not accept, right? That because it's saying that our best forecast for the future appreciation of the underlying, it's simply the risk-free rate. So, when you use this Q, it is as if you were risk neutral. Because if you were risk neutral, it would be okay for you putting money in a risky opportunity, getting back RF, because you don't care, right? So think about utility functions. Now I'm going back to finance one. Okay, when is the case that it is okay for you not having paid a risk premium?
The Q isn't what you're not doing is like standardizing for you to compare all the investors taking away their risk aversion parameter.
Yes. Okay, you say something correct. So everybody does understand what he was saying.
That probability less
So,
compare among investors.
Okay, you see, I'm totally sure that you know the mechanics of these formulas very well. So I'm trying to help you understanding the financial economic impact of these formulas. So when I write that formula, and now I forget the origin of Q, but in any case, I'm saying that the most likely outcome, according to this Q, for the price tomorrow or 1 month or 1 year from now of the underlying is the price today capitalized at RF. Okay? Then we say this against the risk aversion, because if that was the case under the historical measure, that would imply that you could keep into your cash account your money, and that would be equivalent. So you wouldn't like to take the risk. So if you are risk averse, that statement is by inconsistent with reality. Okay? Now, we know that Q is not the historical probability, so the problem is fixed. But on top of that, the first people who started working with Q, they wanted to attach a name to Q and say, what is Q? And then you realize that Q is a measure, that is a technology that helps you run evaluations as if you were risk neutral. So when you say risk neutral evaluation, it's not that you are really risk neutral. It is that you are risk averse, But then there is this technology, the replication stuff and so on. So you may use the technology so that you can run all your computation as if you were listening to it. Okay? Now to make more effective this argument, I show you a different way of looking at this equation. Okay? So I take now, I bring 1 plus RF on the left and a 0 on the right. Okay? So here I take the expected value under Q, these quantities of ST over S0. This one is going to be equal to 1 plus RF. Okay? So under the Q measure, you have that the expected return of this quantity is RF. Is 1 plus RF. Okay? Now, however, I want to understand what's going on, and so I write this one in this other way. I write it like the sum. So let me write using the pi. So this will be pi st up over 0 plus 1 minus pi st down over 0. And this is going to be equal to 1 plus RF. Okay? Now, I take and divide and multiply this quantity by, well, let me do it in this steps otherwise. Okay, so now this expression here uses the pi probabilities. Okay? Now, instead of using the pi probabilities, I want to go back to an expression that uses the p probabilities. Okay? So I multiply and divide by the p probabilities. Okay? So I write this like p by pi over p st up over 0 plus 1 minus p 1 minus pi over 1 minus p st down over S0. Okay? And this is going to be equal to 1 plus RF. Okay? Okay? So it's very interesting, this expression, because you see that now pi over p and 1 minus pi over 1 minus p, these are likelihood ratios. What are likelihood ratios? Are the ratios between the probabilities for the same state in two different for the two different probabilities. Okay, in the two different states. Okay? So if you are in a general situation, instead of so assume you have Q of omega and Q of omega, you can define Q of omega over Q of omega. Okay, and you call this quantity M of omega. Okay, this is a definition. Okay, M of omega is what you name the price deflator. Okay?
Price deflator.
Yes.
What is the price deflator?
Okay? So in that state, the price deflator would be pi over t. In the down state, the price deflator would be 1 minus pi over 1 minus t. Okay? Why it is useful, this M? Well, because take your Q expectation okay? You see that that expectation can now be expressed as a P expectation. So now I take this expression here and I can write it like expected value under P, you see I have P 1 minus P, and what? M of omega by ST of omega over S0. Correct? So M of omega will be pi over T. This will be M up. This one will be M down. Okay?
That's E to the B, right?
This is E to the, and the P is the means that I'm using now the expectation under the P probability, right? Okay. So what I did so far, I took an expectation under the Q probability, and I simply be rewriting it as an expectation under the P probability. Okay? The only price I pay is that now I have inside the expectation also this M. That is what I named the price deflator. Okay? Why I call it a price deflator? We will have a nice example of that. But what's the meaning of a price deflator? Well, think about M of omega being the ratio between the two probabilities. It might be 0.8 or 1.15. Okay? So what happens when think about M up like 0.8? What happens if you have to add that 0.8? It means that for each euro you get in the up state, the importance for your price today of this additional euro will not be 1, will be 1 by M up, so it will be a little bit less than 1. We say 0.8. The M down, assume M down being like 1.15. So if M down is 1.15, it means that for each extra euro you get in the down state, the value to you of that extra euro will be a little bit higher than 1. It will be 1.15. Okay?
Can you repeat that again?
Yes. So if I express my expectation in this way, now these are the historical probabilities. So these are the probabilistic outcomes, the likelihood of each state. Okay? M will be a variable that depends on the state. So here will be pi over p, there will be 1 minus pi over 1 minus p. Now, as an example, take M up something like 0.8 and M down something like 1.15. So this means that in down, the Q probability is a little bit higher than the P probability. In up, the P probability is a little bit higher than the Q probability. So this M of omega is a weight that modulates across different states the payoffs. Okay? So this is like having a sort of exchange rate. So when you get 1 extra euro in the up state, because of the 0.8, the value to you of this extra euro will be a little bit less than 1, will be 0.8. Okay? In the down state, being higher than 1, this will imply that 1 extra euro in the down state is a little bit more valuable to you than 1. Okay? So by changing M, you are changing the value to you of 1 extra euro. Okay? So it is very important that M is a random variable, so it changes across different states. So recall that M is the ratio between the Q and the P probability. Okay? So this quantity is named the price deflator. So when you look now at this expression here, this expression here, expressed under P, is telling you something very important. It's telling you that under the P measure, to have a rate of return that is exactly equal to RF, you are forced to modulate, to change the relative value of 1 euro in the different states according to this M. So it is true that under the Q measure you have then you behave as if you were risk neutral. But if you look at the same equation now under the P, it is telling you that in order for that to be correct, you have to change the relative weight of 1 euro across the states within your expectation. Okay? So this is very important because it reveals that there is a new player, the person who understood that Lars Hansen got the Nobel Prize for that the M, the price deflator, is the place where you feed back, you put the information about your own preference. Okay? So, what's M? What's the economic meaning of M? Okay? So this is where we can make contact between the CAPM and the risk neutral valuation. Okay? By properly selecting M, we can express our valuations under P and being consistent with the risk neutral valuation. Okay? So, let's rewrite this expression. So, notice that now I bring 1 plus RF on the left. Okay? So, notice first of all, note that what's the expected value of M under P? What's the expected value here? So you compute the expected value of M under P, so you will have in each state of nature P by Q over P, or pi over P, right? So essentially you get that this quantity is equal to the sum over the omega of P of omega by Q of omega over P of omega. This is the sum over omega of the Q of omega. This is 1. Okay? Correct? I take the definition of M. I take the definition of the expectation. For Q to be normalized, the expectation of M of omega must be 1. Okay? In addition, notice that each one of these has to be larger than 0, because you want that the Q probability to be larger than 0 for all the states. Okay? So here, M is nothing more, nothing less than a variable that has a 1 expectation and it is positive across all the states. So now I write this one line, expected value under P of M plus RF. Okay? Because the expected value under P of M is 1. Okay? So what I learned here is that I can write this line, expected value under P of M of omega of what? Of S3 of omega over S0 minus 1. This is equal to RF. So this is telling me that once I adjust for M, the expected value of the excess return has to be exactly equal under P to RF. Okay? Now let's call this quantity here. This quantity here, you usually call it R capital T of omega for your investment S. Okay? So ST of omega over ST over S0 minus 1, this is the return you earn on ST. Okay? And it will be a random return because this is a risky opportunity. Okay? finally, what I have here, I could write this equation like expected value under P of M of omega. Now I take R as capital T of omega, that is the return on the risk investment, minus, you see I bring this RF inside the bracket here, so I minus RF, and this has to be equal to 0. So this is equivalent to my risk neutral valuation formula. Okay? So, does this equation remind you something or not? You saw an equation that is very, very similar to this one in Finance 1, for sure. Sorry? Also in the CAPM, but it's more general. Before the CAPM, you saw formula like this one. So it was a formula where everything was equal, but M was different. Was a derivative. It's related to a certain equivalent. So it was related with the utility. You get a formula like this one when you compute the first order condition, the optimality condition for your portfolio. Because that equation is expected value under P of U prime of W star, that is the wealth at the optimum, multiplied by Rs of omega minus Rf, this is equal to 0. This is what you name the first order condition for the investor. So it is the way you select the optimal allocation. Did you cover this equation?
I think so.
We did briefly,
Yes, then you take the second order and you get the CAPM. Yes. So, why this is important? Because now I realize that the origin of this equation, that is the risk neutral valuation equation expressed in terms of omega, from an economic point of view, is simply a restatement of a condition that it is a rationality condition for the investor. So M, in general, should be expected to be proportional to the marginal utility of the representative investor. What does this mean? It means that in order to have the risk neutral probability, I take the P probabilities and then multiply them by the M. But the M, according to this relation, will be proportional to U prime, the marginal utility. So what is M? It's your preference. It's the aggregate preference of the market. So if you want to move to the Q probability will be the outcome of a product. The relative likelihood of each state of nature, P of omega, multiplied by what? This M, but this M should reflect the marginal utility of the investors. What is the marginal utility? How much you like one state of nature compared to another. Okay? So, because M has to be normalized, M of omega in general will be proportional to U prime of W star divided its expectation. Okay? Now, why this is important? So, usually we assume people are risk averse, right? So we assume that the utility function is concave and increasing. So the derivative of a concave and increasing function is going to be positive, right? And decreasing. Okay? So U prime is decreasing. This means that when you increase wealth, U prime is decreasing. Is this reasonable? So it means that M, as I assumed, in my example, it means that M of omega in general will be higher when you are poorer. Why? It is correct, right? Because do you like more having €1 in the future if things go bad or if things go well?
If things go bad.
If things go bad. So M of omega, generally for a risk averse agent, will be higher in the poor state of nature when the business cycle is in the recession period. Okay? So what we learn is that into the Q measure, you blend together two pieces of information. One piece of information is the relative likelihood of the scenarios. The other part is your taste, the market taste. Okay? So when you change a price, the price may change because it is changing the relative likelihood of an event, a default, but also because your taste is affected. Okay? Very good. So now, essentially, by changing U prime, you change M. By selecting U, you have different valuation theories. In the modern language of asset pricing, to give a new theory, you simply give a new M. Okay? So now, in the notes, I'm not asking you to go, this is further reading, but in the notes I uploaded here, you see this is your M, the definition of your M, it's the ratio between Q and P. You can show that by, for example, by taking formula 3.3, that is a specific specification of M, you know, the M is specified in terms of factors and of variance-covariance metrics. That M will give you back all the arbitrage pricing theory models. Among them, you will have one M that corresponds to the capital asset pricing model. Do you have your own model where you think there is an important factor that should be taken into account? You select an M accordingly, and you will have your own valuation theory. Okay? So by changing M, you change the definition of the Q measure, you change your asset pricing theory. Okay? This, by the way, is far more than you need in this class, but it's important that you know that this is the way modern asset pricing works. Or, for example, do you have a macro theory? I think Tommaso did something. So you have a new macro theory, your macro theory delivers a different definition of M, where you know inflation is in the curve in this M and so on. Well, you feed M in this way, you have a Q, you can price securities according to your macro theory. Okay? Very good. So we are done. We have 10 minutes. I think what we can. So this is, if you want, closes the loop. It explains that when you use the risk neutral valuation theory, you are doing something that's apparently silly. You are not. You are simply hiding two pieces of information. One is the P measure, one is the M, into one single object. The single object is the Q probability. If you are an investment banker, that's all you need. If you are a risk manager, if you want to take risk, you need to have the separate information between P and Q. If you are at the Security Exchange Commission, you have to force people to give both information on M and P. It's not enough giving only Q.
So, there are two questions. So, for bankers, investment bankers, there's one on this side of the capital market.
Yes.
They use Q because they want to price those derivatives and to hedge the risk. Right?
Yes.
As opposed as investors who uses P because they want to maximize based on speculation.
Yes, they want to earn the risk premium, right?
Yeah, and the risk premium is basically, we don't know the future, right? So basically,
exactly. So, you know, the risk premium will be hidden in the parameters of M, right? Because the risk premium is that, we will do an example tomorrow, but, you know, essentially, you are, by adjusting M, you adjust the profits you do, the markups that you have in the different states of nature.
Okay, so based on that, the Q that you use as on this side again, I understand that you use to pricing. So you assume that the value of the option of the derivatives moves based on the risk rate. And that's the part that kind of confusing me. Like, I understand when to use it and why each one uses it. So I just try to understand how using Q hedges for risk on this side.
No. That is the price you should charge if you plan to hedge. Then, putting that money into a liquid portfolio and hedging, you will break even in the end. This is the argument, right? So everything on top of that C0 will be your markup. Okay?
Okay, so like that's like kind of your safety net.
Yes.
For this money.
Wonderful. Great, well spotted term, I will use it. You know, you are not simply giving a price, you are giving a price and a safety net. Okay? So this is what you call a quantitative approach to finance, right? So I'm not simply giving, okay, I think it's worth 50. I think, okay, I give you 50 and on top of that I tell you what you should do, okay? Now, for today I would say from a quantitative point of view, there is plenty of material, even too much. We'll come back to this tomorrow. Now, let me simply conclude with something that will turn to be useful. That is, okay, so what? Okay, now we have a general understanding of how to price these objects. We may think of trading these objects. And usually you don't trade a single option. You start trading option strategies. What are option strategies? Are portfolios of options. Okay? Given that you are going to go through a class exercise where you will manage option strategies, let me briefly introduce the most common ones. Okay? So, first of all, do not forget that once you have C0, the initial price helps you moving from payoffs to P&L, right? Because again, now you take the payoff, you take out the price capitalized at time capital T, and you can plot the P&L for your option. So the option, the payoff is not for free. You know, if you want to buy the option, you will have to pay C0, right? So this will lower the profit and losses by a given amount, okay? Then, which are the typical positions you can take? So, for some reason, people start considering this covered put, that is the top left. You know, this is a position where you are essentially selling a put, selling a call and taking the long position in the underlying. So this is the position of a bank that is hedging the position on the, so it's selling the call and hedging the position, okay? So it's a covered call, not a covered put, the first one, okay? So covered call means I take the short position, I sell the option, and I take the long position. When I'm going to cash in, well, you see, I will have in this case, the strategy will not be productive as a strategy unless the final S is larger than K. If the final S is larger than K, you will have a fixed profit. Okay? Let me shift quickly, on the contrary, to the most interesting strategy by far, that is the bottom left. Okay? In that case, you take a long position in the stock market index, and then you buy a put. This is the so-called protected put strategy. Why that is a great strategy? It was, if you want, it was the most important success until 1987 strategy, option strategy. Well, because you have the nirvana here, you are replicating the payoff of a call by taking a long position in the index, that is the position that most of the asset managers have to take, and on top of that you use, as I was mentioning, the put contract as an insurance. It is granting you that if things go bad, the price collapses down below K, you are not going to lose your money, right? You are going to lose the price of the put, but not more. Okay?
But if, for example, you go long.
Yes.
Long on an option, okay. Imagine the price goes down. You don't do nothing. You simply don't take the option.
No. You know, if you have the option in your portfolio, the put will pay off if the price goes down.
Yeah, exactly. But if you don't take the put, you still only lose the.
No, you lose one for one the dollars that you lose if you take the position without taking the put. When ST goes below K, you are gonna lose one for one the dollars with the index. So there is no, you have a lot of the so-called downside risk, right? Okay.
Yeah, without that, you don't hedge the risk.
You're not hedging, yes. You're not.
hedging, that's
Well,
why
you're not.
it's
Sure, you're not. Yes. So, assume you are a pension fund. This is why this. So, at the end, you have to deliver the money because people has to live with the money they gave you, right? So, putting that put in your portfolio or using a hedging strategy to hedge a position such that the final payoff is that one is the best way for you as a pension manager, fund manager, to have the guarantee that at the end you have the money you have to deliver to give to your.
In that scenario, what do they do? They're putting or they're calling?
Sorry?
That scenario, they're putting, right?
See, they are
They are long the index, they are long the put. Or, you know, if pension funds are so large that it is hard that you find banks that are selling you such a large amount of put. So what they do, they use the delta hedging strategy. So they essentially sell when the index is going down, they buy when the index is going up. By delta, we will see this, by delta hedging you can replicate that payoff. That, this is a good point to stop. Why? Because until 1987, everybody was very happy with this strategy. And most of the pension funds were shifting into this strategy.
What's the bad part of the strategy?
That's the bad side of the story, right? Because we have been assuming that the price is moving independently here because we are in a partial equilibrium framework. But unfortunately, if everybody is on the side, on the same side, so they are willing to buy when everybody is willing to buy and everybody is willing to sell when you have to sell, what will happen to the price? When everybody is willing to sell, the price will drop heavily. Okay, this is what happened in 1987. So this is a story that is told in the around Wall Street. This is a limit of this arbitrage valuation theory. You are assuming that the future state is not affected by your action. But in the market, this is not true, right? Because in the market, your action will affect the price.
Everyone had the same valuation method, so when they had to sell, they had a benchmark to sell, and everyone sold, so the market collapsed.
In fact, if you look at the time series of the prices before the COVID, this is the largest drop in time. Because everybody wanted to sell. And these you know, the pension funds are the whales in the market. Okay, good. So now you take a little bit of rest and Marina is going to, you have today, I think you have to complete the
exercise one.
Yes.
One of the
It's one more.